Okay, all right. So today we are going to go over the possibly the easiest topic you will see all year. Okay, which are the different properties of addition and multiplication. Okay, so all right, let's get started. Okay, all right. So now today we're going to talk about the properties of expressions. Now that particular phrasing comes from the state, I believe, from the regions. Okay, I call it the four properties, but the state calls it properties of expressions on the regions. Okay, so very quick lesson, and then we'll do some examples, and then that's it. Should be a very easy breezy day. Okay, let's go. All right, so these are the four properties. Okay, it's actually not four. It's just I always remember it as four. So if you know it, don't write it. If you don't know it, write it. Maybe the process of writing will help you remember these, okay? Because they will come up, but not often, not very often. That's why we're only spending a day on it. So, okay, let's talk. So the first property, all right, it's called a commutative property, right? Which states that in addition and multiplication, all right? So not for subtraction and division, right? It doesn't matter how you add up the addends or you multiply the factors. It doesn't matter, right? A plus B is the same thing as B plus A. So in other words, 1 plus 2 is the same thing as 2 plus 1. Likewise, right? 1 times 2 is the same thing as 2 times 1. So the way I remembered it, like I always had a problem remembering it in school. And it wasn't until I started teaching, because I had to figure out how to explain it to students, that I figured out what's the best way. So imagine, right, your commute. So sometimes, when people talk, they're like, hey, how's your commute, right? What does that mean? It means going from home to work and back, right? So that's kind of like the same idea, right? If you're going from home to work and then back from work to home, that's a commute. So commutative, right? That's what that means. All right. All right. Second property, the associative property. So the associative property means this. All right. Long story short, if you have three terms, right? A plus B plus C, right? As it is in both cases, or you have A times B times C in these cases, it doesn't matter where you put the parentheses. So if I put a parentheses around the B plus C, it's no different result had I put the parentheses around A and B. Likewise, same thing for multiplication. Now, so here's how you can remember this one. Okay, again, I learned this, how to explain this when I started teaching. So imagine, right? So let's say, you have your friends, right? Let's say it's you and your two other friends, right? So friend number one, all right, the light just turned off, hold on. So let's say you have two friends, right? So it's you and friend number one, friend number two, right? So the associative property basically is saying it doesn't matter who's hanging out with who. So your two friends, friend number one and friend number two, so let's call them B and C, all right? If they're hanging out, that's cool. But if it's just you and your friend B, right, it's cool also. So it doesn't matter who you associate with. Think of it like that. So the parentheses is like an association symbol. Okay, think of it like that. Now, 3 distributive, double rainbow goes without saying, right? And you can go this way also, right? That's all I got to say about that. Lastly, it's not lastly, but addition, the additive property, right? The additive identity. In other words, it's something like this. A or any number plus what will always give you back A? Yeah, 0, right? Anything plus 0 will give you back the original number. Okay, that's the additive identity. Now, think about that. What is the multiplicative identity then? If that's the case. So in other words, not 0, right? What number? So let's say we have a letter number 3, right? 3 times what will give you back 3? Yeah, 1, right? So that's the multiplicative identity. I guess there are 5 properties then. All right. All right, so yep, that's number 5. Okay. All right, now the additive. So one more I gotta show you. All right, this is on the regions itself. Like they're very particular about having this one on the regions exam. So let me use a different color. So for the 6th one, the additive property equality, all it means is this. All it means is this, okay? I wouldn't even bother too much about that, all right? So let's say, right, if you have a minus, it's already here, actually. Let me just solve this with you guys. So we got x minus 5 equals 7, right? The act of having to add 5 on both sides, this act itself, right? Remember what your 6th and 7th grade teacher said? If you add something on the left side, you have to add something on the right side, right? If you subtract something on the left side, you have to subtract something on the right side. If you multiply something on the left side, you have to multiply something on the right side, right? So on and so forth. That phrase itself, the reason why you do that, that's called the additive or multiplicative property of equality. It just means that if you do something for one side, you have to do it for the other. That's it. Okay, now, how did I do? Oh, not bad, 5 minutes. Okay, so let's practice. All right. So let's see. Try 1, 2, and 3 right now, and when you are done, press play. All right. So hold on. So press pause right now. Okay. All right, and we're back. So the first two, right on cue. They're on the 6th property that I talked about like a minute ago. Okay. Now, I just want to say a quick hint to getting these questions quickly and correctly is sometimes you just have to like solve it out. So notice how on the right side here, I start solving out the equation just to confirm that, oh yeah, this is the additive property of equality. Okay. This one, you distribute now. Listen, some of you might say distributive property of multiplication over subtraction. Like, well, the distributive property is multiplication. Okay, so people don't really say distributive property of multiplication. They just say distributive property. The over subtraction thing, that just means this subtraction right here. So don't get thrown off, okay? The other thing that's kind of funny is back in the day when I taught at high school, we do this every 9th grade, right? And sometimes some students, they are absent from school so much, you know, that like sometimes they do these and they would on purpose pick on something they've never heard of. So like they know all the 4 properties, but then they'll pick on something like the conversive property of something, and then they'll pick on it because like they're absent so much that they figure like they must have missed something, and that's the thing they have to know. All right, you don't have to worry about that because you guys watch like every video. So again, if you see a choice that's something that's just like out of nowhere that makes no sense, like the conversive property of like, you know, distribution, like don't pick on that, okay? Like that's not it. That's the obvious wrong choice, okay? All right, I'm gonna move on now. All right, we have 3 questions here. Let me see if I could squeeze this in. Hold on, let me press pause, save you some time. All right, so here we have 3 more questions, and that's it for today. So let's say 4, 5, 6. Okay, all right. So press pause right now. Try those 3. All right. These are short answers, so I think that's good practice for you guys. So it's number 6 actually. Okay. So press pause right now. Okay. All right, and we're back. Now the for number 4, when I was looking at it, I was thinking to myself, so the ability to switch this around, right, from here to here, what property does that constitute? It's commutative. Okay. Now, some of you might say, well, Mr. Ring, I thought it's only subtraction, but I think to get out of that conundrum, you can say this. Well, first of all, 2 reasons. One is these aren't even like terms, so you can combine them. So that way you could switch them around. And second, if you write it like, you could write, remember like last year when you did integers, you could rewrite any subtraction as an addition problem. So technically speaking, even though this is -8 minus 10x, you could technically rewrite it as this, and meaning, right, if you can rewrite it as an addition problem, you can rewrite this as such, its commutative version. Okay, now, the other thing is, right, and this is test-taking strategy 101, right, you know for sure that the distributive property has to be chosen. But look, I mean, look at these choices, right? Like none of them say 4 only, right? So that means you have to pick something. And I know it's not multiplicative, and I know that it's not distributive. I mean, addition property of equality. So it has to be commutative, okay? So that's another way to reassure yourself that your answer is correct. Okay, for the second one, this is distributive, right? Nothing crazy. This one, right? When I add 14a to both sides, my answer matches the test, right? So that means this is the addition property of equality, okay? All right, lastly, this one, what property did the person use? Well, they used commutative property, right? Because all they did was did this, right? They switched the place of the 7. Now, I actually had to look up the answer because I know some of you are thinking, well, what exactly do I write, right? That's all you have to write. Like that's literally the answer key from the Regents exam. It says commutative property because x plus y equals y plus x. So it looks like, right, with properties, if you're asked to come up with a reason, in a written reason, write the property itself and then just give them the rule. That's sufficient. So that's pretty cool, right? Okay, all right. So that's it. All right, 12 minutes, not bad. All right, that's a good day. Okay, thanks for watching. Have a good day, and I will talk to you tomorrow. Bye-bye.
OMG, that was so good.